Good morning. Today we are going to solve the problems from slope deflection method. So we have problem analyze. So we have analyze portal frame as shown in figure. Analyze portal frame as shown in figure by slope deflection method. By slope deflection method. And we have this frame. So AB C and D. So we have 3 meters, 4 meters, 5 meters, and load at B we have 10 kilometers. Here we have constant. So now we will start with. So we have solution. So we have frame, wave frame. Then step 1, kinematic indeterminacy. So we have dk is equal to 3, that is theta b, theta c, and as it is sway, so we have delta. Then we have step 2, fixed end moments. So as no load is between the joints, so we have all fixed end moments are 0. MFAB is equal to MFBA equal to MFBC equal to MFCB equal to MFCD and MFDC. So all these are 0. Then we have step 3, slope deflection equations. Slope deflection equations. So we have first term AB equal to MFAB plus 4EI upon L theta A plus 2EI upon L theta B minus 6EI delta upon L square. And then theta A we have 0, MFAB we have 0. So we have 2EI by 5 theta B minus 6EI delta by 5 square. And we will have 0.4 EI theta B minus, so we have 5 square, so this comes minus 0.24 EI delta. This is equation 1. Then we will go MBA is equal to MFBA plus 2EI upon L theta A plus 4EI upon L theta B minus 6EI delta upon L square. Now we have MFBA 0, theta A 0, And if we will go now, we have 4 EI by 5 theta B minus 6 EI delta upon pi square. And we will get it as 0.8 EI theta B minus 0.24 EI delta. This is equation 2. Then we have MBC, MFBC plus 4 EI upon L theta B plus 2 EI upon L theta C. We will MFBC 0. So 4 EI upon 4 theta B plus 2 EI upon 4 theta C equal to EI theta B plus 0.5 EI theta C. This is equation 3. Then we have MCB, MFCB plus 2 EI upon L theta B plus 4 EI upon L theta C. So MFCB 0, 2 EI upon 4 theta B plus 4 EI upon 4 theta C equal to 0.5 EI theta B plus EI theta C, which is equation number 4. Then we have MCD, MFCD plus 4 EI upon L theta C plus 2 EI upon L theta D minus 6 EI delta upon L square. Always keep in mind, sway is related with your columns, not with beams. Therefore, you can see in MBC and MCB, we do not have delta because these two are related with your beam BC. Then CD 0, theta D 0. So we have 4 EI upon 3 theta C minus 6 EI delta upon 3 square equal to 4 EI upon 3 theta C minus 2 EI by 3 delta, which is equation 5. Then MDC we have MFDC plus 2 EI upon L theta C plus 4 EI upon L theta D minus 6 EI delta upon L square. Now we have changed, it will be 2 EI upon 3 theta C minus delta we will get same 2 EI upon 3 delta, which is equation number 6. Then we have step 4. So step 4, joint equilibrium. So we have MBA plus MBC equal to 0. So we can see MBA we have. So MBA we have 0.8 EI theta B minus 0.24 EI delta. So 0.8 EI theta B minus 0.24 EI delta, and MBC we have. So MBC EI theta B plus 0.5 EI theta C, EI theta B plus 0.5 EI theta C, and that is equal to 0. And from this we will get 1.8 EI theta B plus 0.5 EI theta C minus 0.24 EI delta, and that is equal to 0. This is equation A. Then we have MBA plus, then we have MCB plus MCD equal to 0. Now MCB, if we will see, we have equation 4.45 EI theta B plus EI theta C, and MDC, both we have 2 by 3. So we have MCB 0.5 EI theta B plus EI theta C plus 2 by 3 EI theta C minus 2 EI by 3 delta equal to 0. And we have this equation 0.5 EI theta B plus 3 plus 2. So we have this as MCD we have to take. MCD we have 4 by 3 EI theta C. So it is not 2 by 3, that is DC. So this value we have 4 by 3. And so this becomes 3 plus 4, 7 EI by 3 theta C minus 2 EI by 3 delta, which is equal to 0, equation B. And then we have third summation fx equal to 0, and we have HA plus HD plus 10 equal to 0. Now simply we have this as, so we are going to consider this frame. So we have no other loads. This is the load we have 10, HA. I am showing only horizontal. This is HD and this is 10. And therefore we have HA plus HD plus 10 equal to 0. And therefore HA plus HD equal to minus 10. Now we will find HA. So we are going to consider this as MBA. Then we are going to consider this as, we have again this as clockwise. So MAB. Then we have this as HA. If we will take moment about B equal to 0, then we have minus HA into 5 plus MAB plus MBA equal to 0. And therefore we will get HA equal to MAB plus MBA upon 5. Now we know we have value of MAB. So MAB we have 0.4 EI theta B minus 0.24 EI delta, and MBA 0.8 and minus 0.24. So we have HA equal to 0.4 EI theta B minus 0.24 EI delta plus 0.8 EI theta B minus 0.24 EI delta divided by 5. And we will get it as 1.2 EI theta B minus 0.48 EI delta upon 5. And we will get it as 0.24 EI theta B minus 0.096 EI delta. Then we will have in the same way HD equal to MCD plus MDC upon 3. Now MCD we can see we have here. So we have 4 by 3 EI theta C minus 2 by 3 EI delta. And in DC we have changed plus 2 by 3 EI theta C. Second term as it is minus 2 by 3 EI delta whole divided by 3. And from this we will get it as 2 EI theta C 2 EI theta C minus 4 EI by 3 delta. Now we will put these values in this equation and we will get it as 0.24 EI theta B whole divided by 3 actually. So we have 0.24 EI theta B. Then we have plus 2 by 3 EI theta C minus 4 2 by 3 EI theta C from here, then minus 0.096 EI delta minus 4 by 9 EI delta equal to minus 10. And this equation becomes 0.24 EI theta B. Then we have plus 2 by 3 EI theta C minus 0.54 EI delta equal to minus 10. So we have this equation, and then if we will solve this equation, then we are going to get this value that is equal to EI theta B, we will get it as minus 1.67. EI theta C, we will get it as minus 7.95. And EI delta, we will get it as minus 29.07. And if we will put values in the equation of final moments, then we have MAB 6.31 kilonewton meter, MBA we have 5.64 kilonewton meter, MBC minus 5.64 kilonewton meter, MCB minus 8.79 kilonewton meter, MCD 8.79 kilonewton meter, and MDC 14.08 kilonewton meter. MDC we have minus 14.08 kilonewton meter. So likewise, we have to solve the problems. So we have now with this problem. So today we will stop here only. Thank you.